Hello, I am Alan Willison, and it's my privilege to welcome you to this meeting of the Hartford Astronomy Group. Just imagine being in your back garden, studying the night sky, and you discover that one of the stars seems to have moved. Your conclusion is that it is not a star, but a new planet. That is how William Herschel must have felt when he made the discovery of Uranus. However, before we get on to that talk, a few announcements. First of all, for those of you at the university, the toilets are just outside in the waiting area, and should the fire alarm go off, the emergency exits are just to the sides of the screens at the front. Please put your mobile phones onto silent or turn them off, and we're sure you're going to enjoy the meeting there. For those of you on Zoom, we ask that you keep your microphones muted and your hands away from the space bar, as that has the habit of turning the microphones on again. We aim to finish the meeting by 9:45 so that people at the university can clear up the equipment and clear the building in time by 10 o'clock. For those of you on Zoom, we can carry on a little bit longer and we aim to finish by 10 o'clock. So the format of the evening is, after these announcements, Martin Weston is going to give you a short talk about things you can look forward to in the night sky. That will be followed by the main talk. And after that, the times for questions. People in the university, you can ask them directly. For those of you on Zoom, please submit your questions via the chat facility. Following the questions, just a few announcements from myself about some upcoming meetings, and then we will finish. So, no more from me. I'll now hand you over to Martin. Thank you.
Welcome everybody, and welcome everyone on Zoom as well. Okay, we've got tape then, sorry about that. So, interesting things happening this month. We have a total lunar eclipse, which is due on the 16th of May. It is early in the morning, so you have to get up if you want to watch it. But it's mainly visible over South America, most of North America, parts of Europe and Africa. So depending where you are in varieties, what you're going to see depends a bit on luck. I think we'll still have a good show. So people in the UK will not be able to see every part of the eclipse. We will still be able to see the lunar eclipse totality with the entire moon turning red. The moon will start to enter Earth's shadow about 2:30 BST, which is American time, but they're an hour ahead. And the full eclipse will occur just before 4:30. The entire eclipse lasts for more than 5 hours, ending at 7:50 AM. So observers in the UK will only be able to see the eclipse to 2:32 to 5:10 as the moon will set in the horizon. The optimal viewing time to see the eclipse is between 4:29 and 5:06. So a period of totality in London, where the moon lies entirely in the Earth's umbra, full shadow, will appear red. So I'll put here a little video clip, just to show you what's going to occur. So initially, some of the moon goes into the P umbra, and starts to go dark. So it's showing there at 2:15. Then it moves into the umbra at 2:59, and you'll see it start to go dark, and then it will become red. It becomes red because of the effect of the Earth's atmosphere, the wavelengths. Blue wave light tends to be diffracted, so you tend to see it in red on the long wavelengths. The 4:11 there, general eclipse, and we'll go back into the pre-umbra, and then just darkened. You'll see the section going across there. Eventually we'll finish. So if you get an opportunity, if you don't mind getting up in the morning, at the moment it does look like we've got a clear night, so hopefully we'll have a chance to go and see that. So a little bit of an explanation of what's actually happening there. You can see the sun there, and the Earth is in the way of the moon, and it's casting a shadow. So, the little clip now, but the lunar eclipse occurs when the sun and Earth and moon are in perfect alignment, and Earth's shadow blocks the sunlight from reflecting off the surface of the moon. Although the moon does not disappear completely, instead it will turn bright copper red colour. So there is a picture of 2018 when I was in Spain that I managed to capture, the last one that was visible for me anyway. As you can see, that's quite a nice colour. So a little bit here about update on what I've been talking about, the James Webb Telescope and all my talks, and just a little bit of an update. I've just completely downloaded this whole narrative from the NASA website, so I'll just read it. The thermal stability test puts NASA's James Webb Space Telescope through its paces, from hot to cold. Meanwhile, work on the last phase of commissioning is beginning, which involves delivering into the specifics of Webb's research equipment before beginning running normal scientific operations in the summer. We will finish commissioning by measuring the detailed functioning of the science equipment. Now the telescope is perfectly orientated and the observatory is approaching its ultimate cryogenic temperature, we can begin to at last set off operations before research organizations begin. So that would be exciting. Another little thing I found on the web, which I thought was quite interesting, Hubble has discovered a star hiding behind the corpse of a star, adding weight to an explosive theory. So this star, this companion star, has been siphoning fuel from the star that's gone supernova, which actually caused it to go supernova. A little bit of an explanation there. This international team of astronomers used observations from the telescope to confirm the existence of a companion star to the supernova. The discovery clears up a mystery about supernova chemistry, as well as helping researchers to understand how giant binary stars work. The supernova novae are vast explosions in space created at the end of a star's life. They carry layers of elements around them, hydrogen gas on the very edge. If there's no hydrogen around a supernova, as in the case of supernova 2013GE, something must have been stripping it away pre-explosion. What might be siphoning hydrogen, researchers say that it's a companion star, which is hidden by the supernova's brightness. A bit here about gravitational waves. We've been hearing a bit about gravitational waves just recently. Thought this was quite interesting. A bit of research by the US Naval Laboratory Corporation of Communications in Washington. They talk about low frequency waves stretch out so long that even traveling at the speed of light, it takes years for each wave crest to pass through the Earth. Waves are produced when a pair of black holes, millions to billions of times more massive than the Sun, spiral towards each other. Such pairs are formed when galaxies, of which harbours its own supermassive black hole, collide and merge. Many black hole mergers are occurring throughout the universe, each producing gravitational waves, and they will fill space within a gravitational wave background. So next, I just want to show you some more pictures from our astronomy, astrophotography section. What I normally do. So this first one here is by one of our members, Kevin Noble, which is a beautiful picture of the Seagull Nebula. I hope you can see that all right. Seagull Nebula, also SH2 296, lies just on the border between the constellation of Monoceros, Unicorn, and Canis Major, Great Dog, very close to Sirius, which is the brightest star in the night sky. The nebula lies more than 400 times further away than the famous star itself. The complexes of gases and dust form the head of the seagull, glows brightly in the sky due to strong ultraviolet radiation, coming mostly from one brilliant star, HD 53367. Excellent picture, Kevin. Thank you for giving us that. Next one is one of my images, which is of the North American Nebula. It's so cool because I can't quite see it there because I haven't got a wide enough field, but if you look at the shape of the nebula, it appears to look like the North American continent. So its vicinity is close to Deneb, which is the brightest star in Cygnus, Cygnus 1. The nebula is famous, as I said, because it resembles the North American continent. It occupies an area of 120 by 100 arc minutes and has a visual magnitude of 4. It lies approximately 16,000 light years from Earth, and its MGC listing is 7,000. Interesting, just a little point there. If you look to the right-hand side of the image over there, you can just see the start of an area called the Cygnus Wall. This is an area of star birth, so there's a high concentration of hydrogen and other gases that allow stars to be born. Move on. This is an image from Steve. This is quite a good image, actually, of some galaxies. Peculiar interaction galaxy NGC 3718, also called R214, is a warped S-shaped spiral galaxy in the constellation of Ursa Major. It's interacting with this other galaxy NGC 3279, 52 million light years away. But interestingly, if you look right at the top of it, you can see up this top section here, right in the very top corner, you can see the Hickson group 56 can also be seen clustered around NGC 3718, which is consistence of 5 interacting galaxies and lies over 400 million light years away. Brilliant picture, Steve. Thank you for that. Move on to another one by Kevin. This is a really excellent image of the Jellyfish Nebula, and he's got some really good detail here. So a little bit, Kevin just says there, whilst he was grabbing galaxies with his 8-inch Ritchie Rutillion, he decided to add this 2021 capture of the Jellyfish Nebula. So there was 11.5 hours of total of data gathered for this particular image. Sorry, an example, total of 56 hours, which could take me a few years given our weather, which is true. We haven't had much opportunity to do much imaging this year, it's not been good, but when we have, I'm really impressed with the club's performance, the photographic section, and what they're producing now. It's just absolutely fantastic. I love this next image of Steve's on the sun. It's a double stack experiment with the whole sun with 2 inline Etalon filters to increase contrast. Taken from his back garden. Well, done, Steve. That's fantastic. Good detail on there. You see the sun is far more active than it's been for a long while. Moving on. Close up of a bit of activity there. Superb detail again, Steve. And finally, a little joke to share with you. You might find that amusing. I've been there. Well, that really is the end of my little talk. So I'll hand over to Jerry.
Thanks, Martin. So a number of you here, I know, do your own observing, and but our subject tonight has to be someone who could be described as having made the greatest back garden amateur observation ever. We're going to hear about William Herschel, who died 200 years ago this year. Our speaker, main speaker, Mike Dworetsky, I first met, I'm trying to work this out, it's got to be at least 20 years ago, probably more than that. To show you how well he's known, when he arrived this evening, a previous student of his recognized him
Car park.
outside and said hello. Well, Mike's worked at a few places that you might have heard of, like Mount Wilson Observatory, Mount Palomar. So before spending 35 years at University College London, where he became director of their observatory, which is sited way out in the country at Mill Hill, or it was when it was first set up. Can we just have a show of hands? How many of you have been to Mill Hill Observatory? Okay, it's a great place. I mean, not just for what it contains, but little details like the Saturn design of the door handles.
My idea, but the skilled machinist's production.
Okay. And do you want to transfer to Mike's presentation? Then, if that comes up. Oh.
Take a couple of seconds.
Okay. Because
We are.
there we go. You can see we have two names up there, and our second presenter, Isabel Thompson, and you can see that each of them have a number after their names, because that's the names of the asteroids which have been named after each of them. Isabel is a professor of no,
Honorary researcher.
researcher in archaeology, again through University College London. I've been to Herschel's house in Bath. I'm sure some of you have as well. It's an incredible place, very exciting to look around. And I'd encourage any of you who can get over there to do so. But to hear about the person who lived there and what he did, and hand you over now to Mike Dworetsky.
Okay, well, good evening, everybody. Thank you all for coming, and all of you out there in Zoom land. Good to see you. Well, are we on Zoom? Yeah, okay. Well, today I'm going to talk about William Herschel, and I titled this talk Backyard Astronomy in the 18th Century, because in fact, all of Herschel's observing was done from the back garden of one or another of his houses. This is our man, William Herschel. This is a portrait, I think the best portrait of him, done in 1785 by Lemuel Abbott. Lemuel, what a name. The only other Lemuel I know of was Lemuel Gulliver, Gulliver's Travels. So I was pleased to see that it's a real name. And he was a very well-known artist who did lots of portraits of officials and naval officers, including a famous portrait of Horatio Nelson. And one thing about Herschel, of course, don't forget, he was a well-known professional musician long before he became an amateur astronomer who turned professional with the support of King George II. Was it second or third? By the way? Second, yeah. One thing he did that might come to your notice is that in Bath, the most fashionable resort of the time, everybody from London society would make a beeline for Bath during the summer especially, but also during the year to take the waters. And they needed entertainment. And so there's a handbill from Herschel's benefit concert of the Messiah, and you'll notice that he's got Miss Herschel there as one of the vocal parts. That's his sister Caroline, who's a very fine soprano, and others. And he also, I believe, not only sang in the presentation, but also conducted and possibly played one or two musical instruments as well. I don't know what he was doing. Well,
Not all at the same time.
not all at the same time. That's very difficult. And you notice the bottom, it says tickets, 5 shillings each. This is a benefit from Mr. Herschel at 19 New King Street in Bath, and at the rooms, the new rooms. We'll come back to Messiah and Herschel's music a little later. What about some of his scientific achievements? Now, everybody has heard about his discovery of Uranus. He's very, very famous for that, and his name would never be forgotten. But he did lots of other things in pioneering ways. The construction of large telescopes, reflectors, very unusual back in the 18th century. He devised some instruments for solar observing. You know, the main problem is to reduce the intensity of the light to such a level that it would be safe to look through the telescope. I'm not going to say any more about that, but there is a device called a Herschel wedge, which he invented, which removes about 100,000 parts. Well, it only lets through one part for about 100,000, which is what you need, what we would call the neutral density 5 for safe viewing. He made systematic studies of planets, Venus, Mars, Jupiter, and Saturn. You'll see some of his drawings of Saturn a little later. He studied Mars very carefully and was able to improve the accuracy of the rotation period of Mars, as it was known then. He also, with his larger telescopes, found several satellites of Saturn and Uranus. He used micrometer to measure asteroid sizes because, as far as most people were able to decide, these were point-like objects in the solar system. He was able to see a visible disk on a couple of the very largest ones. I think it was Ceres and Juno. He also discovered double stars, but that was almost by accident because he was looking for something else. He was looking for a method to determine stellar parallax, which was the great goal of astronomy all through the 16th, 17th, 18th centuries and onwards. And Tycho, for example, didn't believe in the Copernican system because he couldn't find parallax of the planets with his accurate observations, naked eye observations. Think about it. The nearest star is less than 1 arc-second of parallax. So, of course, he couldn't have found it. He also discovered many nebulae clusters, some of the ones that we saw pictures of here tonight. If they are NGC numbers, that's from Herschel's catalog initially. He made systematic analyses of star counts in different directions in the sky and discovered that the local star system was more or less a flattened, sort of thick pancake shape. He determined the solar motion with respect to other nearby stars. I'll say more about that later. And he discovered solar infrared heat. He was able to prove that it was similar to light in its properties. They didn't know about the wave nature of light then, didn't know about the particle nature of light then. All they knew is that all he was able to find out was that energy in the part of the spectrum below the red was actually stronger than that in the visible. Well, we'll say a few words about Herschel. I'll leave this slide up if you'd like to just speak to this one.
So Friedrich Wilhelm Herschel, he was one of the 10 children of a bandmaster in the Hanoverian Guards, and he was born in Hanover in 1738. And all of them had to earn their own living. William's first musical job was as an oboist in the Hanover band. The Elector of Hanover and the King of England being the same person, George II, movement between the two countries was relatively easy. And in due course, William came to England and held various positions as an organist, as a music tutor and a performer. And he was organist notably in Halifax in the north of England. He worked there for some time. And then he played the oboe in the orchestra that performed in the Pump Room in Bath. And he moved into 19 New King Street in Bath in the year that the street was built. Within a few years, he was director of public concerts at the Octagon Chapel and conducted there the first performance in Bath of Messiah, as you've seen in the handbill. New King Street. For some time, here it is. It's and you can see the number 19. You can just about make out the blue plaque outside the front door of number 19. I hope it's there on the left. It's quite a narrow street, but it's very Georgian, a very Georgian street of houses, tall and narrow. And in fact, when you're in the front drawing room on the upper floor, you can see straight into the opposite windows. So, yes, and so there's a certain closeness to your neighbours. However, but for some time they lived at number 7. He and his brother Alexander, and later on their sister Caroline, and they still had to share the house with another family. And this was quite normal in those days. You rented properties, and so you could move very easily from place to place. And having your own house was fairly exceptional. So sometime after they had lived in number 7, they moved into number 19, which is the one with the plaque. And this time they had the whole house to themselves. And this is the place which is open to the public and owned by the Herschel Trust. And he developed an interest in astronomy. And Mike will now explain a little more about how he came to do that.
One story I have heard is that Herschel came home from the pump room one evening after doing a performance and found a man out in the street with a telescope looking at something in the sky. I don't know what it was, possibly the moon. And he got very interested in this and said, I would like to study astronomy. He thought about it. Now, the man who he was speaking with had a very fine, small refracting telescope, which was an achromat, which was the latest thing that had only been invented about 20 years earlier. But he decided he really wanted to know about astronomy and how to do it, what it was all about. So he got his hands on as many astronomy books as he could. He tried to assemble his own telescope and purchased optics. This turned out to be a little bit like what you might call a cereal box telescope, not up to much. So he decided that he could not afford to buy his own fine, small refracting telescope, and that was actually very good for the rest of us. Instead, he decided to make reflecting telescopes. I wonder if anybody here has ever made a telescope from scratch by polishing their own mirror up. No, these days you don't get very many people doing that. Back in what I was called the olden days when I was a boy, quite a few amateurs would still build their own telescopes, polish their own mirrors, and work out exactly what to do from reference books. And Herschel decided to do this, and finally in 1774 he made his first successful reflecting telescope. This was a Newtonian design, focal length of 5.5 feet. And a couple of years later, he actually built a 20-foot telescope of what's called the Herschelian type. So one of the things he did was come up with a new idea for a way to look through a telescope. There were reasons why they did this. A Herschelian telescope, the front view type. Nowadays, if you had a really big reflector, you would use a prime focus. And in the olden days, the astronomer would actually ride up in the prime focus cage, take a lift all the way up to the top, climb down in, and on cold nights, you'd have to plug in a heated suit into a little socket. Those were the days, and ride up there and have them help you if you needed to do a wee in the middle of your observing. Okay, but with Herschel's design, the only thing was that the telescope had to be large enough in diameter so that your head would not seriously interfere with the view of the light coming in. So the reason he did this not only was to save expense and effort, but also to reduce the number of reflections. And this is another telescope by Herschel. This one was found at Observatory House in Slough, which I will come to much later. The Newtonian, and the reason for that is that it's too small to be a Herschelian. So we had a flat mirror to reflect the light to the side up at the top end of the telescope. And it was actually one of these 7-foot telescopes that he used to discover Uranus, which I'll come to in a moment. So in 1779, Herschel decided that just going out and taking pot shots at nice objects in the sky was all very well, but he wanted to do something a bit more scientific, a bit more systematic. And remember, he was an amateur astronomer, but a very gifted one. And so in 1779, he began a systematic survey of the sky and kept on working and working at that. He set the telescope up and used the rotation of the Earth to bring objects across the field of view. And he did this from his back garden at 19 New King Street. They had a very nice clear view down to the south. On 13th of March, 1781, a strange object drifted across the field of view of his telescope. And he described it in his notes. Herschel was very good at taking notes. At the bottom of that, you'll see it reads, he's got very good handwriting as well. In the quartile, I should use a German accent, but I won't. In the quartile near Zeta Tauri, the lowest of two is a curious either nebulous star or perhaps a comet. In fact, he thought it was a comet at first. It says a small star follows the comet at 2/3 of the field's distance. What he means is the diameter, I think. You might notice if you look up at the top, you see some of his notes about the night before, looking at Mars. I think there was some frost or mist on Mars. And we're at 53, that's at 5:53 in the morning. I'm greatly sure there is a frost on Mars. And through a small telescope, Uranus would look very much like the picture on the upper left, just a small dot, slightly larger than a star. How many of you have seen Uranus through a telescope? Fair number. It's not very hard to do. You'd have to find it. That's the main problem. But it's quite obvious. It's a fairly bright object. It's around 6 magnitude. On the right, a picture through a somewhat larger telescope, and here you might be able to see some satellites, I'm not sure. If you had a really humongous telescope like the Keck giant telescope in Hawaii, you might find views somewhat like the ones on the bottom, possibly not seeing the rings of red, but you can see the planet quite clearly. But not many of us get a chance to look through the eyepiece of a 150-inch, actually bigger telescope. Well, in 1782, after the discovery of the planet, he published a catalog of the double stars that he had found. And he visited Maskelyne, Neville Maskelyne, the astronomer royal at Greenwich, who invited him to come to get Greenwich to demonstrate his telescope. And it was very obvious that the optical quality of the telescope was superior to anything they had down at Greenwich. So already they're going to be jealous. They'll want one. So immediately people started ordering Herschel telescopes. Herschel actually made quite a lucrative sideline out of making telescopes like the 7-foot for sale to wealthy hunters, let's say. Life at 19 New King Street took on a new reality after the discovery of the planet. They became increasingly devoted to astronomy. He set up a workshop in the basement. Brother would make mechanical parts using a self-made lathe. Sorry? That's one here. That's the one I believe that Alexander actually made himself. A very fine little piece of kit. And over here on the left, you see Herschel in a drawing, presumably by imagination, busy polishing the mirror, and Caroline there faithfully helping him by feeding him while he continues to polish, because you can't stop halfway through and take a break. Again, what he needed to do, I don't know what she would do. But he would carry on for several hours until finally he just had to drop from exhaustion, but he kept the job done. And made quite a bit of spare change out of these telescopes. Now they were made of speculum metal, and I don't know if you've ever heard of speculum metal. You're more used to the idea that mirrors were made of glass and silver, or later on made of glass and aluminized. But that's the sort of thing you would buy nowadays. It's a great advance in the later 19th century and early 20th century to have silvering. And when I was at Mount Wilson, they still had the tanks, equipment that they used for silvering the mirror when it was first put in the 100-inch telescope. And the 60-inch also had something similar. And they only switched over to aluminizing in, I think, about the 1930s. It was a long story. What?
You were not there in the 1930s.
No, I wasn't. I did have to give that one a miss. Well, speculum is a mixture of copper and tin, about a 2-to-1 mixture, and they usually had to add something to it, like metals such as arsenic or antimony. In most cases, it was arsenic, which you had to be careful with, as you might imagine. Speculum was very shiny, highly reflective, but it had one drawback in that it would tarnish very quickly. That was a disadvantage of silvering as well, but the silver you can strip the coat and start over. The speculum, the only way you could get the shine back is to repolish the mirror, which meant refiguring the last stages. Their attempts at casting were done in the basement. There we are. This is part of the basement in the house. And there is that's not really the furnace they use. That's using a plugged-in light to make it look as if it's glowing. But they would make attempts at casting speculum mirrors from molten metal in the basement. Caroline joined in. Crossed out where it said enthusiastically.
Yes, I think because Caroline had arrived in Bath as a singer, she found herself keeping house for her two brothers. And I think partly, I imagine, because William, once he started his survey of the heavens, was up at night constantly. She decided that rather than put up with this, she might as well join in, which she did. She was she was more than just the person who made the coffee, although she did do that to keep him awake at night. And she also kept detailed diaries. And it's from her diaries that we get quite a lot of the information about life at New King Street and in Bath, and when they eventually moved to Slough. So she describes the attempt to make one of these mirrors, and it involved making a mould using horse dung partly. Why is not terribly clear.
Very good thermal properties.
Yeah, thermal properties, as you say. And the mix of metals was altered. They tried a second time, and the result was disastrous. The metal, there was 538 pounds of this stuff, and they were melting it in the little scullery at the back of the house, which you can see here. And it began to leak through the bottom of the furnace into the fire and poured across the floor. And she wrote, both my brothers and the caster and his men were obliged to run out at opposite doors, for the stone flooring, which ought to be taken up, flew about in all directions as high as the ceiling. So the flagstones you can see in that photograph are replacements, presumably, and they were nearly all killed from the sound of it. So that was the end of that particular experiment, to cast something quite so large.
I will add that subsequent efforts were successful. And they didn't have that kind of disaster again, but the one disaster really made an impression. Well, in the house, very comfortable house, very nicely appointed. This is the drawing room. You've got I think it's a celestial globe rather than a terrestrial globe. A portrait of Herschel above the fireplace. A big window to look out across the street into the house across the street and see what they're up to. And just a very comfortable room, and the family can relax there. No televisions, of course, not even radios. They can sing to each other and also practice some music. And Herschel also would teach his pupils. He was quite involved in being a music tutor. He would teach his pupils in the music room, which was also upstairs. Out in the garden, not far from where this is, Caroline and William, especially William, went out one night and, as you heard, discovered Uranus coming through his telescope field of view. Thought it was a comet, but it turned out that it was indeed a planet. Now, you saw his notebook, and I always use that as an example to students of how to keep a good notebook, because that A, proved what he saw, B, it described what he saw, and you can't dispute what he did see, taking careful notes of times and what it looked like and so forth. There are other astronomers who did observe this planet even before Herschel. The best known of these are probably Pierre Le Monnier, who was a French astronomer at the Observatory of Paris. And he, in fact, observed the planet about 12 times, at least, noted down its position, but his telescope was somewhat inferior. He didn't distinguish it from a star, and he never did repeat observation to check what he was seeing in the sky. He assumed anything point-like that he sees is a fixed star. But it was great that he did this, because eventually astronomers were able to go back, use his data, and deduce the orbit of the planet very quickly, and decide that it was indeed not a comet, but a planet. Comets move, as you know, in elliptical orbits, and planets in orbits that are also elliptical, much more nearly circular, and they found this very quickly in this case. So they knew right away it was a planet. I won't go into all the questions of what were they going to call it, eventually they did settle on Uranus. There was Herschel was one name somebody suggested. No thing, that's a bit over the top. George's star was Herschel's idea. And one reason for this, well, I'll come to that in a couple of moments. Now, astronomers expressed a lot of skepticism about Herschel's claims of using, I did magnification 1,540 times, and I saw, Martians running around or something on the surface. But in fact, Herschel really did make very small eyepieces. As you know, the smaller the eyepiece, the shorter the focal length, the higher the magnification. Herschel's most powerful eyepiece there was barely 1 inch in length, and I'm sure you would lose light if your eye was fully dark adapted looking through that thing. The ocular lens is very small. So you get very high magnifications, though I'm not sure exactly how useful those are. But skepticism was not warranted. He really did have these very high magnifications. Herschel was asked to demonstrate his telescope to King George III at Windsor. The king was very impressed. He said, I'd like you to be my royal as my king's astronomer, and I'll set you up with a stipend of £200 a year. Your duty is to move house to Datchet near Windsor and be available whenever I wish to show royal parties and guests the wonders of the heavens. And so indeed, that's exactly what happened. Herschel took up these royal duties. They moved to Datchet, and he continued to do his astronomy. Fortunately, the king was interested in astronomy, but not so interested that he was a pest. And as a result, Herschel was able to get on with his work quite well, and only occasionally he would have visitors. And he was a very sort of easygoing fellow, and he was more than happy to have visitors come and look through the telescope once in a while. This carried on throughout his entire working life. Herschel published a number of papers during this period of time, other than his most famous paper, of course, is An Account of a Comet, actually about the planet. One of his discoveries was to plot the motions of stars, their proper motions, across the sky, and see whether there was any systematic movement such that stars, if the sun was moving through the field of stars in the galaxy, we're moving towards a point in the sky, stars there would not move as much in proper motion. But the ones to the side, 90 degrees away, would be moving rapidly, appear to be moving as the sun and solar system moved ahead. And this is a little hard to see this diagram, but the idea is that if you had a nearby star and the Earth and the sun rather moved from one place to another over the course of a couple of years, the stars would move quite a bit across the sky, but distant stars would not move very much. I don't know if I can raise the pointer here. Here's the distant star, here's a distant star. They're not moving very much in the sky. The proper motions are small. But nearby stars would have much larger proper motions. That was the idea that he based his work on. He actually did a reasonably good job of this, despite sort of what we call picking and choosing his data. But he came up with a result that showed that the sun and the solar system were moving roughly in the direction of the constellation Hercules, or possibly Lyra in that part of the sky. And even today, more refined proper motion studies show that he was not more than about 10 degrees out. And remember that proper motions were very, very primitive measurements in those days. He also used star counts to try to establish the rough just shape of the local star system. And he found that in some directions towards the Milky Way, there were lots more stars in the field of view than there were if you looked out 90 degrees away towards what we've now called the galactic poles. And so he drew this diagram in this other paper showing kind of in a schematic way. He didn't actually say that the system was a rectangular solid. This is just an illustration of the idea that it was flat and thin. He thought the system was bifurcated, that is, that it had a split in it, as you can see on the left-hand side of that diagram. In fact, we know that was caused by interstellar dust that he didn't know anything about. One of his great discoveries, in some ways more important than the planet, was the problem of double stars and parallax. And Herschel had an idea to use two stars that look very close together in the sky and look for an annual shifting back and forth of one of them relative to the other, where the nearer one would move and the one behind would stay in place. The trouble is, he didn't realize that most double stars in the sky, if they're close, they are physical pairs and not just line of sight coincidences. So his idea was to use double stars to look for a differential parallax of one star against another. That didn't work, but he did discover double stars, and towards the end of his life, he accepted that they were physical pairs. Any good statistician could have told him this 20 years earlier and saved him a lot of worry. But he made many observations over the course of several years, and as a result of that, he found orbits of the stars, and they were moving in orbit around one another, putting the universal in Newton's universal law of gravitation. Herschel's moved to Old Windsor, and at this point, the King George III was very agreeable, and he asked him to fund a 40-foot focal length telescope that would have a 48-inch diameter mirror. And they moved to Slough, and a place that was later named, christened Observatory House. I don't think they built it. I think it was already there. Just got a new name instead of a Burnham Cottage or something. In 1788, finally cast a successful mirror, 48 inches in diameter for a 40-foot telescope, and it's a biggie. So they moved to Slough, and this is a contemporary illustration of the 40-foot telescope. Coincidentally, it's also the subject of the first photographic plate taken by his son, John Herschel, and it also formed the basis of the badge of the Royal Astronomical Society. That's a different story. But here you see two gentlemen at the base of the telescope in the garden. Of course, there was no dome, so you had to just protect it against the weather as well as you can. You might want to say something about it. I will put it now.
So this is a model of the 40-foot telescope in the Slough Museum, and is operated by ropes and pulleys and had speaking tubes, so that William could converse with Caroline. And I think you can see in the model there, there's Herschel at the top, and Caroline sits at the bottom. This is really the image that is used for the sculpture in the garden in Bath, because Caroline was up all night as well, taking notes. And so, although we assumed that it was actually William's handwriting in that notebook, he may have written all this up afterwards, and it was Caroline who scribbled down what she could in the dark She brought the coffee and was generally essential. They hired local men to do the heavy work of hauling the machinery around. This was so that William's dark vision wouldn't be ruined, and he would shout down instructions to the men as well operating the telescope. And it was this telescope which was visible from coaches travelling along the Bath Road from London to Bath as they went through Slough. And it was pointed out by travellers. There's in fact the first edition of the I think what must be the local 6-inch map of Slough, because in fact it shows the railway line which opened in 1838. And if you look a little closer, you can see there's Herschel's telescope in big letters. The observatory house was just in Windsor Road, just south of the crossroads in the middle of Slough. It was demolished eventually in, I think, the 1960s for road widening. But it's the topography is otherwise very similar. And there's the station to the north. And also on the map, if you look at the bottom right-hand corner, you can see Upton. And this is Upton Church, that's situated just down there as well. And the road leading from Upton towards central Slough and Windsor Road is Upton Road. And there was an account, this is Caroline's account, I imagine, of the construction of the 40-foot. Large numbers of locals were employed in building the telescope, with timber scaffolding nearly 50 feet high and a fully movable circular foundation with speaking tubes. The gigantic sheet iron tube was assembled in a barn at Upton and carried by 24 men along Albert Street, that's the road along it, and up Windsor Road to the house. And if I drive back from further south through Windsor and Slough to get to Harrow, where we live now, I have to sit at the traffic lights just there at the corner of Albert Street and look up the hill to just where the observatory house used to be, and then drive along Albert Street and get the road that leads northeast. So they assembled in the barn at Upton, carried by 24 men along Albert Street to the house. The king, of course, came to view the stars along with many others. And so, in fact, this is not Caroline's words, because this is where it says that Herschel was renowned for his good nature and patience, as well as his astronomy, and put up with all the visitors who came to see the giant telescope.
That sounds familiar.
Although I just have to add that in fact it was demolished in the 1820s, and
What, 19?
no, later on.
Which?
Well, no, not the house. The telescope itself, and it must have been later than the 1820s, because John Herschel and all the family stood around it and had a requiem for because it had long since fallen out of use, and this was after Herschel's death, which was 1822.
Herschel was a very skilled draftsman, a very skilled drawer of the planets that he saw and other objects. One of the things that he drew, this is before Uranus was discovered. The dates on these, I think, may not be able to see it, but March and April of 1774 on the left. The rings edge on. But on April 3rd, 1774, the rings disappeared. You could see the shadow, but you could not see the rings themselves. So Herschel was able to deduce, as astronomers had been for some time, that the rings must be very, very thin compared to their extent. A few years later, he drew Saturn with the rings open, and he also saw a large white spot on part of Saturn. I don't know if this is a temporary or permanent feature. I think it's something that comes and goes on Saturn. But you see there's a kind of an indentation in the main equatorial band. And that's another picture of Saturn that he drew. And here you see 3 bands on Saturn. Next to it is, well, you can't really reproduce photographs that well in printed material back in the 18th century. That's his picture of the ring nebula in Lyra. The hint there is at the bottom of the picture where it's the 57th, and you know that's N57, the ring nebula. And that's what it looked like, and didn't actually have speckles in it. That's how you can draw it and get it printed. One of the great things that Herschel did was conduct a very serious scientific investigation. This is more than just looking at something. This is thinking about solar radiation and what it consists of. And in those days, they didn't really know much about light. Physics was not very far ahead. They knew about diffraction, so they knew about the wave nature of light to some extent. But Herschel put the light of the sun through a prism into a darkened room where the light of different colors could fall on a set of thermometers. And the basic idea illustrated in the diagram, if you put a band of light from the sun onto the thermometer, you can watch how much it rises in temperature and use that as a measurement of the amount of heat you get. And so on the left here, you see his actual experimental setup, which involved a number of different thermometers and a prism to refract the light of the sun, different colors. And on the right, you see what he found was actually so astounding to him that he actually wrote it up. And some of the things, some of the words he uses actually are remarkably prescient. The thin dotted line there, with the colors written underneath, are the visible light. And that is a measure of how much the thermometers went up, essentially, as each of these bands of light came through the prism onto the table. So on the right-hand side, the thin line is the apparent light, which is measured, but the solid black area is a plot of the amount that the thermometers went up. So light intensity is the thin line, but the amount of heat measured by the thermometers is the dark area. And what you can see is that the peak of the energy received from the sun was way beyond, or just at the edge of the red spectrum. And that this continued on a considerable distance further into the infrared, below the red, or beyond the red. So he believed from this that heat rays and light rays were probably the same thing, but that heat rays were invisible to the eye. And so now I've just repeated part of what we already saw, but Herschel carried on and carried on. In 1803, he was about 65 then. He decided being a bachelor wasn't really what he wanted to be. He married a wealthy widow, as don't we all try to, if we're men. What's her name, Beckham? They married a wealthy widow named Mary Pitt. They had one son named John, who was later a very famous astronomer in his own right. I'll say something a little bit about it later. In 1816, Herschel was hang on, now. Herschel was knighted and elected first president of the new Astronomical Society of London, later the Royal Astronomical Society. Now, John continued his father's work by taking a telescope, one of the telescopes, I think it was the 20th telescope, to Cape Town in South Africa, and observing the southern sky so as to complete the work begun by his father, which is only in the northern hemisphere. And he succeeded in doing this and extended the catalogs of nebulae, double stars, and whatnot considerably. And he also extensively studied the amazing and bizarre behavior of the star that we call Eta Carina. Anybody heard of Eta Carina? Yeah, Eta Carina, for a while was one of the brightest stars in the sky. Is now believed to be some sort of strange, sort of slow supernova or something's going on there. It's a very, very active object, much, much fainter now. But it got up to, I think, first magnitude briefly in the 1830s. John observed it along with his other astronomers who were at the Cape. Her Majesty's astronomers had the Royal Observatory at the Cape of Good Hope. So they moved to Cape Town. He completed his father's survey. And one remarkable fact about his time there, it's not William, but John, was that he and his wife, Mary, at one point had dinner with two persons who were visiting from a Royal Navy survey ship. The name of the ship was HMS Beagle, and the people were the captain, Robert Fitzroy, and his science, what we might call his science officer, a certain Mr. Charles Darwin. Now there would have been a dinner to fly on the wall. Curiously, very little is said in the diaries of either party about the event, although Mary, I think, was the one who actually recorded that they met Mr. Darwin when the ship was in town. I'm not sure that Darwin's diary actually mentions it, although I may be only seeing the abridged version. The Voyage of the Beagle was published as a book and was a very big bestseller in its day. Anyway, William Herschel died in September 1822 at Observatory House in Slough. He was buried at the nearby parish church at Upton. And roughly about the year 2000, we don't know the exact date, he was a stained glass window was placed in the church to commemorate, well, actually to commemorate the solar system, but seeing as how their most famous guest person, body, the most famous person in the churchyard was William Herschel. They came up with a design that honored both the planets and Herschel for his discoveries. So here at the top you see Uranus, you see several other planets. At the bottom you see image of, well, possibly William, maybe somebody else looking down the 40-foot telescope tube and studying objects in the night sky. So he's although one of Britain's greatest scientists of the day, he's not buried in Westminster Abbey, but they do have a plaque on the floor dedicated to William Herschel, 1738, 1822, Celorum Perupit Claustra, which translates as He broke through the barriers of the heavens. And we'll have the final word, of course.
So when he was 76 in 1813, Herschel had met a Scottish poet called Thomas Campbell. They met in Brighton. And Campbell later recalled that, speaking of himself, he said, with a modesty of manner which quite overcame me, when taken with the greatness of the assertion, I have looked further into space than ever human being did before me. I have observed stars of which the light, it can be proved, must take 2 million years to reach the Earth.
Okay, and that, and the end, yes. Now, of course, that's not the end. It's not even the beginning of the end, the end of the beginning. Just one last question before I turn it over to questions from the audience. If Herschel said he could prove that light must take 2 million years to reach Earth, actually, we know that probably wasn't strictly correct. He was off by a factor of 10 or so. But how did he make that deduction? It's a question for the students' exercise book. Maybe people want to discuss that a little bit. Herschel was truly a great character, a man of great personal integrity and virtue, and we don't see many people like him anymore these days. Okay, well, thank you very much for listening to us. We'll be happy to take questions. You may have noticed it says alibi sepultus, which doesn't mean he did it, but he's got an alibi. It means he was interred elsewhere.
There's a question on Zoom.
Yes, please.
On Zoom, the question is, when William was conducting his sky survey, how did he record his results?
In a notebook. I mean, he was writing down everything that he saw. I think Caroline was there taking notes. So we're not sure whether that was his handwriting or not, but in that, on that page I showed, I think it was his handwriting. But to a large extent, she would probably take notes for him. Again, because of the problem of dark adaptation.
Yeah.
If you have to turn on or light a candle or something every time you want to, or use a lantern every time you want to make a note, you're not going to have very good dark vision.
I imagine that she took down rapid notes and he wrote them up the next day.
That's very possible. That's why it looks like it is William's handwriting.
Right. But would they have noted the position of each object that they were looking at?
He would note the time of observation fairly precisely, and from that they could. Caroline had to do a lot of calculating because she would calculate from the exact time that something went across the transit.
Right, and they knew which direction the telescope was pointing.
Yes,
and that gave them the position in the sky.
That's right. Well, they mostly used it as a meridian transit.
Yes. Yeah.
That's how they would get right ascensions and inclinations.
Anyone in the room then?
We have another Zoom comment.
Yes, okay.
So Jeff Bryant says, can somebody at the university please thank the presenters for one of the most interesting and informative presentations on the topic of the history of astronomy I have ever heard. So.
Absolutely.
Oh, thank you. And I guess that means you're going to have to put it on YouTube now.
Oh, yes.
We had a little email exchange. He said, would you be willing to put it on YouTube? And I said, yes, if it's good. But no.
No, in fact, I would say that, I mean, this, well, frankly, we do not do academic lectures here, but this has been a presentation that the style of it has been such that we can all not only follow it, but enjoy it. We've learned a lot about it and about William Herschel and his work. And I'd like to thank you both again very, very much.
Thank you for inviting us.
Thank you very much, Jerry. I'd like to endorse your comments about giving thanks to Mike for such a fascinating insight into the Herschel's life and discoveries. I'd like to thank also Martin for the talk at the beginning of the meeting with those super photos illustrating the talk. Thank you very much, Martin, and everyone who contributed photos towards that. Our next meeting is actually in a week's time, the 18th of May, when it's the annual general meeting of the Hartford Astronomy Group. Now, I really would like to encourage you to come along to that. And we have two vacancies that we really need to fill. The first one is that of secretary, and that will involve taking minutes of the meetings and distributing them to the members and dealing with various other day-to-day administrative issues. If you feel that you could do that, please get in contact with us and we will get you sorted for that. The other position that we've got is for an understudy for Steve. As you can see, Steve has been very busy this evening getting the videos and the audios all sorted out. It's quite a job. And should Steve not be able to come along either through work commitments or any other issues, then we're going to be stuck and it would just be a Zoom meeting only. In order to prevent that, if we've got somebody out there who would be interested in finding out how it all works, would be again delighted to hear from you. You don't have to know about it immediately. It will be a learning process, but we really do need somebody to come along to put that guarantee in place that all our meetings can go on. After the 18th of May, the next meeting is one of HAGAS, our astronomical imaging section. And they've got a meeting where they've got their great photographer coming along, Nick Shemanek. Those of you who know Nick's work will know that he is an ace at taking photographs. It really is a meeting not to be missed. Now that will be at 8 o'clock in the evening at the Stanboroughs Club, which is in Hoddesdon. Members can go along to that meeting. So please have a look on the website, you'll find the details there, and I'm sure that you'll have a terrific evening. The next meeting for the Hartford Astronomy Group is on June the 8th, where we've got Martin Hardcastle from the University of Hertfordshire giving us a talk on the environmental impact of radio galaxies. I'm sure, again, that's going to be a fascinating talk, so get your tickets and come along to that one. And finally, just to say thank you to everybody, whether you're in the university building tonight or whether you're on Zoom. Thank you very much indeed for coming along and making tonight a successful evening. Those of you at the university, have a safe journey home. And those of you on Zoom, well, you can stay on a little bit longer if you want to chat to each other. Thank you very much, and I look forward to seeing you all in the near future.